Good morning or good afternoon and welcome. My name's Sarah and I'll be your host for today's webinar. For your information, today's session is being recorded and will be made available on the Juniper Learning Academy. If you have any questions during the presentation, please type them in the Q&A pod, which you can find at the bottom of your screen. And the questions will be answered either during or after the presentation. So thank you very much for taking your time to attend this webinar today. And to start off, I'd like to introduce your presenter, Mr. Eric Osberg. Thank you, Eric. The floor is yours.
Okay, thank you, Sarah. And once again, thank you for joining. This is, as you can see, part 2 of the DC Bootcamp we are running. So my name is Eric Osberg. I'm a partner systems engineer. And with me today, I also have my colleague Mutu, and he will be helping out. So one thing he can help out is by, if you have any questions, please use the Q&A box. We will try to address them as soon as we can. Mutu will help, and I will do my best also to answer your questions during this session. And as you know, this session, is the second one. And for those of you who attended the first one, which was 2 days ago on Tuesday, we talked about some DC architecture fundamentals and telemetry together with the Paragon portfolio. Today, it will be only around Apstra. So talking about what is intent-based networking and do some demo, how you can build using resources within JCL, and also how you can build your own in your own premises on your server. And also in the end, how you can quote Apstra for specific use cases. And then the part 3, which will be on Tuesday next week, we will have 2 parts. It will be DC security, which is around not only how you can protect your private data center, but also what we can do in the cloud with the VSRX and so forth. And last but not least, for those of you who have customers or for you partners who have your own, you can say automation framework based on Ansible, we will then look into how we can use things and playbooks to make it easier that Juniper Professional Services has done for 7 years, and as of I think in December last year, made them public on GitHub. So that's an alternative to Apstra if you want to use controllerless. So that's the series we're doing. What about today then? So this is the agenda. I appreciate this is a pretty long session, so we will have a break like after an hour or so, or a little bit less. But before the break, I will do just an introduction. What do we actually mean by intent-based networking? Because it's could be a little bit frustrating sometimes. What do we mean by that? Even more important is to understand do's and don'ts. That's where we actually set the boundaries, you could say, of Apstra, what you can do and what you cannot do today with the current software version. Then I will start off with the first demo showing how to build a spine leaf network from scratch using resources within JCL before the break. And after break, then continue doing some more day 2 operations, meaning like troubleshooting in spine leaf, say using the same setup as before the break. And then continue with something that is quite useful for you if you want to have your own virtual network, or sorry, a virtual lab, I would say, on your own premises installed on your preferred server. And last but not least, there is some promotions we have out there as of May or June this year. That's good to know, and some packaging around that to make it easy for you as a partner and customer. And then last but not least, also some resources that could be useful in terms of training and so forth. And for those of you who attended the session on Tuesday, you know pretty good what this slide tries to illustrate. So this is, today focus is Apstra, but we have like an ecosystem around that. And on Tuesday, we discussed the QFXs because that is more or less needed for building a fabric together with Apstra. And optionally, you can also add some Paragon Insights, formerly HealthBot, or Paragon Active Assurance for further and more advanced telemetry within a data center fabric, for instance. And if you remember, next week, then we will then follow up with some DC security, public cloud, and controllerless DC. So once again, these things interact to some extent with Apstra and some do not. For instance, I didn't gray out this, but Contrail is something we will not talk about. We still have Contrail around, but it has been a little bit reshaped, you could say. So I will briefly touch on it later on, but that's separate sessions. But today, Apstra and intent-based networking, and for those of you who have been around some time, you know probably what this means to some extent. So we're going now into something we call simplified operation. And as you will see then, by using intent-based networking, we simplify and abstract, you could say, the data center network by using Apstra, and Apstra can do day 0, day 1, and as you can see also day 2. So that's what Apstra is very much about. And one thing, a good thing, maybe a takeaway, is like this is in short what Apstra is all about. Because I know some people shortly might ask you, what is Apstra then? And this is kind of an elevated pitch. So what it is, it's a software that provides day 1, day 0, day 1, day 2 operations for data center networks. And it also includes all the life cycles of the network. And then it integrates not only with Juniper boxes, but is a multi-vendor solution. And what is also important is that the software continually monitors, automates, and validates, meaning looking into is the intent actually working as intended, and doing that in real time. And the outcome of this is reduced OpEx and management complexities. So this is like an elevated pitch. You can take or leave, but it's summarized pretty good what Apstra is all about. But a little bit more data is Apstra. The keyword is, once again, intent-based networking, and we'll talk more about this, but it's one thing to remember, this is like a multi-vendor solution, and it will be a multi-vendor solution moving forward. Some partners and customers ask, why do you want to do multi-vendor and not only focusing on Juniper? Well, the answer is like, we are seeing requests coming in there that either customers want to do multi-vendor, or they want to use Apstra for only maybe Juniper, or maybe even Arista. So for us, it could be even an insertion point in the Arista network to use Apstra and maybe then add security, SRXs, or maybe the Paragon. So the multi-vendor will continue. And also we have we also have Sonic, which like is an operating open source operating system, which is becoming more and more popular within some customers. And that is something that, for instance, Dell are promoting heavily, the Sonic. And sometimes when Dell's customers are requesting some kind of fabric management tool, we have done business together with them using Apstra. Speaking about insertion points, we also have integrations with third party, and in terms of data center, VMware, vCenter, and NSXT. So we'll touch a little about that. And that could typically be one discussion starting point for you together with your customers. If they have VMware, which is quite common, especially with the enterprise market, and see how you can insert Apstra for that specific use case. What you will see, and hopefully, is like the ease of use. For those of you who've been looking into Mist, this is like the Mist for a data center, you can say, because going from installation, getting like onboarding devices, and actually building a data center with EVPN Islam is quite easy. For those of you who have been looking into Contrail in the past, this is by far more easy to install and maintain in many ways. And that is very much indicated by here, by one of the customers that says that going from the POC to production is like less than 2 weeks. And another thing, what we're doing then here is like, we are using something I will show in the demo called rollback. And that's, for most of you familiar from Juno's devices, that you can do rollback configuration of a box, with Apstra, you can do rollback of the whole network. So let's say you're during a maintenance window and do some configuration changes using Apstra, and for some reason it's not working as expected, you can then, by just clicking one button, go back to the previous configuration of the whole network, which you know is stable. And it's very much about TCO saving. And what does that mean? Well, it's about how you can save time in deploying, designing, and maintaining your data center. So very much about OpEx. So this is one thing that customers appreciate. And of course, it's like seeing, believing. So we think that if you do a POC or do a demo, usually then customers understand, this looks good, I want to proceed with this. And of course, Juniper, we like open standards. So within Apstra, even though today we will mostly show you how to use the graphical user interface, there are ways of integrating with external applications and so forth using standardized APIs such as REST APIs or Ansible, if you prefer. It says here self-driving network. Yes, we do have the building blocks, but the solution as of today is not self-driving yet, but most likely it will be in a couple of years, which means then that if you do changes and Apstra realizes something went wrong, it could actually fix that problem on their own and maybe only notify you. I can see here we have a question. The question is there an Apstra compatibility matrix? I think what you mean then is like what kind of devices we support, and we will look into that later on. I hope that was the answer to the question. Otherwise, please rephrase it and we'll try to answer it again. But intent-based networking. So this is something that was not around until Apstra came around, you can say. So according to what the Apstra people say before being acquired by Juniper, when they met with the Gartner, they saw something new, and then they more or less invented the word intent-based networking. And what is that? Well, as network engineers, we like to do the nitty-gritty stuff, meaning we like to actually go into the boxes and do the configuration and see everything is up and running. But instead, we could do the other way, which means that instead of doing the whole configuration directly, rather going on like a 10,000 feet view and describe what is it I want to do. And what could be like, I want to build an EVPN VXLAN fabric. I want to have 2 virtual networks. I want to use VXLAN, so forth. And I want a DCI using over the top, for instance. Those kind of high level, what I want to do. So this is what you then insert into Apstra. And what happens then with Apstra is actually taking those high level what things you have defined and make them then into configurations for each and every boxes. And then eventually once that it has been created, sent out, and you have an up and running network according to your intent, what you described. And then also very important is like once your fabric is up and running, you need to show is it actually working as my intent. Because maybe there are some changes, some actually people do afterwards after launching fabrics, they make changes into boxes. And that is not according to your intent. And that will be reflected and seen in the Apstra UI. So quite easily you will see if someone, for instance, go and do just a configuration, a temporary one in any of the QFXs or whatever it could be. And then you get an alarm, and quite quickly you can see what is the root cause, and then you can see, do I want to do this or not? Or you can then revert and go back to your intent from the beginning. Good. Okay, I think I answered the question then. So we're moving on. As described, Apstra is not only about designing, deploying, and operating. There's also other things involved, but that's the main thing. And one of the main thing is like we will look into is like Apstra is the single source of truth. And this is quite important because what that means is like Apstra has the full knowledge of all the boxes, of course, but also all the configurations and all the relationships between, for instance, your virtual network, the VXLAN, how you do the DCI and so forth. So any changes is always known by Apstra, and that's like the single source of truth would know that. That is actually the background is the graph. It's similar to what Facebook is using. So it's the relationships between, in this case, interfaces, boxes, virtual network, and so forth. And that's how it usually is. I mean, a network is built. It has the relationships. And as you can see in the further bottom there, we support then Juniper, of course. We can do Cisco. We can do Arista. We have also integration with VMware and SXT, the Sonic one, Dell, MNC, and also EdgeCore. So once again, open platform and has this single source of truth we'll look into further on. But on a very high level, what's, I mean, like the key features then of Apstra? First of all, the intent-based network, I think probably, hopefully describe what that is. Instead of describing like how you should implement it, rather tell this is what I'm looking for on a high level, and then use Apstra to transform that into configuration, you can say. So the single source of truth, that is very important. For those of you who have been running networks, usually you have maybe runbooks, Excel spreadsheets, you have other things where you document either the configuration or who is doing what and so forth. You won't have to do that now by using one database for everything. And you will see that. And the closed loop assurance is like we are, by using Apstra in day 2 operations, constantly looking into is the network working as expected or your intent. So we're feeding telemetry from our devices into Apstra to see is the network expected to work, is this network working as expected, sorry. And if it's not, you might use the time Voyager rollback. And briefly discussed and said that this is like you can go back with your network configuration, not box configuration, network configuration, to a stable previous version you know works. And within this platform also, we have this fabric management capabilities. For those of you who have been working with Contrail, it was similar. So this is like where we then could, and by using Apstra, we could then manipulate the routing protocol, in this case BGP, in order to get traffic out from a leaf or spine. And once you don't have any traffic on that specific device, then you can do an upgrade, or you can do an RMA, whatever you want to. And I will show that later on in the demo. Last but not least, as I mentioned, flexible integration means it's a very open platform in that sense. We can use other things to integrate REST API or Ansible or Python in order to build things within the fabric. And that is actually one thing we do, which I will show you briefly in this build your own data center using total virtual environment with Apstra VMXs and virtual QFXs. But I think before we show that, it's also once important, what do we mean by an intent? And this is even more details on what we with Apstra mean by that. And that is, I think, quite easy to understand from a networking point of view. So first of all, I mean, we think, so how many spines and leaves do I want? I mean, what kind of interface is it 10 gig, 40 gig, 100 gig, whatever? And also on the server side, I mean, how many NICs are we doing? What are the speeds of it? And functionality? Will there do any dual attachment, meaning that from the server will it be attached to 2 leaves, for instance, for redundancy? And of course, speaking about external thing, of course, if you have DCI, how is that supposed to be connected? do you want to do like over the top, or do you want something else that we mentioned and Mutte described on Tuesday? And of course, on top of this, we have this virtual network, the overlay. I mean, how do you want to do that? How many virtual networks do you need? How about the VXLAN and VRFs and so forth? So that's the intent that you then put into your graphical user interface, or they're using the APIs. And by doing that, then eventually then Apstra will build the configuration and send it out. And one important thing is like a logical device. And what is that? That's close to Lego. I mean, most people understand Lego. So in this case, you say, for instance, I need this kind of logical device that has, for instance, 400, 100 gig uplinks, and maybe 20, 25 gigs for server connections. And that's like a logical device. And then I will map that into an interface map. I think that will be more seen than in the demo. And once you have done this, which is all, once again, just virtual, you have to see this kind of interface map. What kind of device, physical device, maps into this? And for the same kind of interface map, you can choose then between Juniper, Cisco, Arista, whatever, depending on what you have in your network. And speak about this single source of truth. It's like people ask, where do you actually store the configurations? Well, we do not. We rather than use the graph where we have all your intent, which was previously described in the previous slide. And as shown here in the slide, like you can see then the connections between the system, the spines and the links and so forth. And by using the graph, then we can derive the configurations and then send them out to the devices. And this is like, I will show you then once we have a network up and running. On your left, this is typically the logical way how a spine and leaf network could look like, having 2 spines, 4 leaves, and a couple of servers. And that is equal on your right side. This is once you have run the deployment and looking into the graph database, this is what it looks like. And just to make sure that 99% of times you don't have to care about this. But there is some ways of doing queries into the database, and you can manipulate and so forth. But most of the time it's just there in the background and you don't really have to care about it. And if you go into really big networks, it looks a little bit messy. But so on the right then it's like on the left, that's like the physical network, like a 3D animation, which is actually built into the Apstra graphical user interface. I can show that later on. So once again, huge networks, looks messy, but please, you don't have to actually understand that, because everything this happens in the background. More importantly, is like, why do we have this, and how does this help you as either as a partner or a customer? Well, first of all, we don't have to store the device configs. So as long as we have the database, we can always then derive the configurations directly from that. And since this being the single source of truth, if we do any updates, that will be recorded by Apstra, so we don't have to do any runbooks and so forth. And that also goes for the Visio diagrams if you have. Everything here is within the platform, so if you do changes, you will have that in the database. And of course, you can easily then see what's happening in the configuration. And that also goes for the cabling stuff. So if you do then build a network using Apstra, and you build first the configuration sent out to the devices, and also you can then actually pull out a CSV file, for instance, with all the cablings. So for those guys who are doing the cabling, you have design, you have deployed the network, then you can ask the guys to please do this cabling, and then they can show exactly using the CSV file how the network should be connected and the cabling is done. Speaking about reference design, I think we mentioned it a little bit on Tuesday by Mutu, but Apstra comes with like some predefined functionality. And what we could do then, we can do like a 3-stage class or a 3-stage class. Five-stage class. So, and the 5-stage class, as you can see on the right, that's where we introduce super spines. So for where you have multiple pods, or if you have larger networks, typically then you can include super spines if you want. But of course, if 3-stage is fine, that could also be used. So as you will see, for instance, in this build your own lab after break, we have a 3-stage and a 5-stage class in the same Apstra installation. And as discussed on Tuesday from Muto, is like in Apstra, we only do eBGP. As we could do iBGP, we could do like, we could do route reflectors and so forth, but we have chosen to standardize on eBGP. And the reason for that is like, yes, if you want to do this manually, it's more complex for sure. But please remember, this is, we're using Apstra to generate and also do all the configurations. So the complexity is within Apstra. You don't really have to care about it. And this is, as you know, as discussed, the reason for this is like standardized. Yes, it could scale to any size more or less, because this is like what typically the Facebook guys doing and Google and so forth. They like doing layer 3. And as you know, BGP has been around for more than 2 decades and is the foundation more or less on the internet. So it's stable. And more importantly, we can also include new things like eVPN into the BGP for distributing certain things related to the eVPN. So that's the thinking. So eBGP is happening in the background, but you really don't have to think about it, because that is totally handled by Apstra. More importantly, if you want to do some external traffic, that is using something we call border leaves. You will see that in one of the demos. So that is not done directly from the spines. So we have external routers then talking to the leaves, and external routers then are that's where we could introduce, for instance, routing policies on BGP, how we should distribute the routes being received from external routers on the other end, for instance, a DCI. Speaking about the reference, how it works, I mean, it's a distributed design. And as you know here, we could then use the ERB version. So we have the VTAPs are always on the leaf. The spines in this case, we don't do CRB, we only do ERB. And when you talk about routing protocol externally, the only one we do is BGP or static. What's good to understand is like, how is the communication done from Apstra into each and every device? Well, actually we have for each and every device, we have for Unos-based devices, we have a container, a Docker container dedicated for each every device. So in this case, we have 5 containers. Each container then is dedicated to a specific device, and we do netconf over SSH to send out the configuration and also to retrieve any telemetry from the devices into the Apstra for the day 2 operations. What we introduced then in the during summertime, then we have something called connectivity templates, which you will see in the demo. That's to make it more scalable and easy to connect things actually into the fabric. We also have the NSXT integration. We'll touch a little bit more on this, and this once again is a good insertion point for you with customers using VMware. And last but not least, we have the Enterprise Sonic, which is like the open source networking operating system, which is coming quite popular and is being used, for instance, by Dell quite heavily. And that's also a way that we can support that. But the NSXT then, what is that? Well, first of all, it's always good to know this is only for read-only from NSXT. So that means that from Apstra, we can then pull information from the NSXT into the Apstra environment. And what does that add? What kind of features, or what's the value we do then? Well, if, for instance, for NSXT to work, you need to get some VLANs in place, and those VLANs has to also be configured in the fabric. So sometimes there could be a mismatch. So that's one thing, that if an NSXT then want to have a VLAN configured in the fabric in order to NSXT to work, that might be seen then, if wrongly configured in NSXT, in the Apstra side, and we can see, this VLAN, for instance, is missing, and then we can quite easily see that how rather fix this, or it could be an application. So it's like quite powerful to see that by reading information from NSXT into the Apstra environment. And the connectivity templates, what is that? Well, you will see that, but that's like a framework where you do then almost like click, like I want this virtual network to be connected to this server, and so forth. So it's quite straightforward, which you will see then in the demo. And I mentioned earlier then, what about Contrail then? How does that go with Apstra? Well, there's virtually no interaction today. So what Apstra does, as you know, we build an underlay and overlay for the data centers. If you then want to build an SDN overlay, you could then potentially use the Contrail, but that is today has no interaction into the Apstra UI and so forth. But it might be for some customers and some partners, one thing you want to look into. Okay, any questions before we move into the next part? I don't see anyone. So the next part will be like how you qualify a customer and see, is Apstra actually the right solution for you or for them? So first is like qualifying the design and operations. So there are some limitations within Apstra, which is built in by design. So we have two columns here, do and don't. So the do is, yeah, we do support, and don't, we do not support. So on the architecture side, as discussed, we support an 3-state, 5-state class. We only do like pure, also we can also do pure IP, I mean pure layer 3 only and no overlay, using eBGP. Still, we only do, if you want to do any routing, we only do ERB, no CRB. And we could do that with also, if you want, have a pure layer 2 bridge overlay supported, that is also a thing. And this scales to hundreds of devices if you want in Fabric. From an operational point of view, yes, we could do this also using the Apstra CLI, which I will not show. This is my more advanced way of doing it, or with Ansible integration, that you actually can build things using Ansible playbooks. I mentioned the VMware, so that's where we have integration in place. There is on JCL VMware integration for vCenter if you want to look into that. Tech preview or roadmap, what is that? I have further on a little bit slide description. But what it is that in terms of functionality, we have something we call collapsed fabric. That is actually where you collapse the spine and leaf into one box. And this is typically then maybe for very small data centers, or maybe like a disaster recovery site. And we also do like global-based policy, which you could consider like micro-segmentation. So that is now supported on ACL with UNAS, and also some IP version 6. What you should not support, or if customer is asking for, unfortunately, that's not something we can do due to the design of Apstra. So we cannot do like MCLAG or virtual chassis fabric or virtual chassis. Also, for those who are running OpenStack, we don't do ML2 integration, which is like Neutron, a networking part. Up until quite recently, we had some integration with Nutanix, but unfortunately not anymore. And that also goes for the Cumulus. So I've taken away the Cumulus in some of the slides. It might pop up, but the Cumulus is not supported anymore. For underlay, as mentioned, we do eBGP, not any OSPF or link state database routing protocol. And that also goes for the IBGP, eBGP only. And once again, that works. Not CRB, because we want to do the routing, the VXLAN routing, we want to do that on the leaves. So that's by design. And for any very complex server, multi-home servers, we don't support two extreme ones. We do support up to three ways of connecting a server for redundancy, but not more. Inbound management is not supported, so you actually do need like a physical port into the management port of the devices. What will happen hopefully in the future, we'll do policy-based routing, the MAC VRF, and UNOS EVO as an EVPN VXLAN as a leaf. Currently, we can do EVO on spine, which you will see later on in another slide. And then we have exports only. What is that? Well, that is a little bit more complex. It could be done, but for instance, if we have a brownfield, we will require some professional services in order to migrate from a brownfield into Apstra. So Apstra is by far better for greenfield. So if I would make a recommendation, please see if you can go into greenfield rather than brownfield, but there could be solutions for brownfield as well by using professional services. High availability, well, that requires like using VMs and similar, which could also be done, but it requires also some professional services. OISM, that's like some advanced multicast within the fabric, and that could be done by configurators as well as VXLAN stitching, which might be even more important. And the configurators is actually where you do a portion of a UNOS config, which you enter into the Apstra graphical user interface and then send it out. And there are some limitations on what we can support. I will show that in the demo. I think this was one of the questions that recently that was asked is like, what kind of devices do we support? And if you remember, for those of you who attended Tuesday sessions, our data center portfolio is wider than this. As you can see here, we support some small EXs, yes, even a 12-port version, all the way up to the PDX 10,001 and then the QFX 10,008. But as you can see, we don't have the ACXs yet. We do not have the QFX 5700 or the 5130 and so forth. But that is on roadmap, but usually this is more than good enough. If you look into quite popular things like MaxSec, if you want to do that, yes, we could do that, but that's using configurators. So that is like a little bit more advanced, but we could do that, for instance, for the 5120 M version, if you want to do that. MX and other things are also supported, but those are like unmanaged, which means like it's a generic system. And generic system could be a server, it could be an MX, it could be PDX, apart from the PDX 10,001. So that is supported, but not fully as much as for those devices listed here. When it comes to EVO, which is like a different kind of operating system, which is supported, for instance, in the QFX 5700, the 5130, and also on the ACX platform, we do not have EVPN VXLAN leaf support yet. So that is coming in 2022. So that's a device that you qualify. So what next then? Well, the last thing is like on the EVO, which is maybe not so common yet, but we can use it like a spine or a super spine, and of course in any like IP only role. Of course, as mentioned in the previous slide, we don't have the EVPN VXLAN support yet, so that would be, as mentioned, in 2022. And then that is like, first of all, listening to, qualifying that what kind of architecture, what kind of device and so forth. But then in the end, then you have to look into what kind of features are they looking for. And I will not read through all the all the features here on the do side, because this is not everything. There's more that is supported by Apstra, by the reference design, you could say. Rather look into on the right side what is not supported yet. So SFlow is not, or SourceNet. And it's not maybe right to say it's don't support it, because we could do like MACsec, port mirroring, and storm control, DCI, VXLAN stitching, and so forth by using configlets. But once again, it will require some experts to do that, but it could be supported. And what is also important to understand, I realize this is a quite small font, so you might not be able to read it, but if you go to juniper.net, for instance, you will see and search for tech preview. This is something new, I think, for most people working with Juniper for many years. But it's common within other software companies such as Red Hat or Google have had this for a long time. And what it means, tech preview, as it says here, is like a feature is as is. So in terms of support from JTAG, for instance, yes, you could have some support, but maybe not all the support you are used to for a fully supported device. And it even says here in the end that the tech preview is not supported under existing service agreements. So why do we have this? Well, this is like introducing new and usually requested features from partners or customers. For instance, in the later version 4.01, you can see here what is like in tech preview, like collapsed fabric. And this is like having only two devices, that is spine and leaf, in the same device for a rather small site. So that is tech preview. And also that goes for the layer 3 access list and access switch layer. Those three, usually what happens then is like in the next release, which is like 4.0.2, will become GA, which means fully supported. So that is what I have done so far. Tech preview is short after being announced, usually going into GA, and that's fully support, and the JTAG will have whatever happens. And before the demo, I just want to show something which could be a little bit confusing. As you know, on the MIST side, we're also talking about configuring EVPN and stuff, but there are some differences. And one of the key thing, of course, is like Apstra is on-prem, MIST is a cloud-based. And also when it comes to supporting what kind of deployment scenario, Apstra is by far more used in data center, while the MIST is focusing on campus and branch. And that goes where if you look into supported architecture, for instance. So in Apstra, we have this 3-5 stage or collapse fabric, which is more data center centric architectures, while the MIST are supporting more campus feature architectures like both ERB and CRB, for instance. And when it comes to platforms, actually this is wrong. For the QFX 10K is not supported by MIST, but we have similar support for platforms. And you might ask, why is the QFX going into campus? Well, that's like a dual persona, you can say. So that is on purpose. So moving forward, as you know, a QFX could fit in a data center environment, or it could be in a pure campus and branch environment as well. So depending on the software and use case, you could say. Okay, any questions out there? No? I don't see any question. I'm sorry, can't see any question. So now I will move into the demo part. And the demo, before I show you what we're going to do, I will then go into and show you what platform I'm using. So in this case, this is from JCL. So you can use it after this session. And it's even so that you could give it out to your customers, because anyone that has registered partner or customer can get access to this for a couple of hours and play around. And what is more important is like there's a good step-by-step instruction. So everything I will show you here could be found in this, which is quite rare on JCL, very good step-by-step instruction where you can define the racks, do an operation and monitoring and so forth. So I would really recommend you that search for Apstra on JCL or VLabs and do a reservation and play around by using the step-by-steps, and then you will be able to I think quite quickly to understand what you can do with Apstra or not. And this is like the setup. What we're trying to do then is like, if I go back here, so this is like a high level view, what we're trying to achieve. So on the left then, of course, you have Apstra, and those Apstra will be connected to this, in this case, only 4 virtual QFXs, 2 spine, 2 leaves. And then we have simulated 3 bare metal servers, and 2 of those will be in the same virtual network, which is the blue, and 1 is actually only in their own virtual network. And then we'll also build some EVPN VXLAN on top of this, like the overlay, and then see how this looks like in the GUI of Apstra. And this is like the workflow from day 0 to day 1. If you remember, we will look into the day 2 after the break. So in order to do the design and to the deployment, that's just a few steps you need to do. So in this case, I have already done the first one, which is onboarding. What that means is, like, if you remember, you need out-of-band management. So you connect your switches, in this case, over out-of-band network, and then you get like a basic setup of your boxes in order for you to be able to connect with netconf and SSH. And that requires this off-box agent, which I will show you. And then the next thing you need to do then is like adding resources, which I will show you. So with that, I will show you step by step how you do this. And what I've done, as you can see, there's no blueprint, and the blueprint is actually a working data center, you can say. So what I do have done so far, I've created some resources. But before we do that, I just want to show you, for instance, the agents. So what I've done before this is just take some time. I've created these 4 agents. And if you remember, we need 1 agent per device. In this case, a virtual QFX. And then once this is up and running and communicating with your devices, you can start configuring your network. But in order to do that, we need some resources. And what is a resource? Well, first of all, within the fabric, we need some IP addresses. And what I've done here, as you can see, I have already defined, I can click on this. I have created a network, in this case, a /24 network for DC1 leaves loopbacks. And I've done the same thing for the spines. We also need, of course, some IP addresses for the links between the spines and leaves. So I will do then like an intra fabric and just creates a subnet. I can pick anyone more or less, but in this case, I do just slash and create this. So now I have a pool of IP addresses for loopback and for the intra fabric, and also needs, of course, some AS numbers. I've created that already for the spines, and we'll do similar for the leaves. So DC1 leaves AS number. And in this case, I will use, and of course, you can use a lot. In this case, I over provision by far. So now I have two pools for the AS numbers. The VNIs, that will be, of course, needed as well, but I use it as a default pool, and Apstra will then pick VNIs from this pool when being configured. So now I've done the first step, adding resources into Apstra. The next thing is to build a rack. So, and what is a rack then? Yeah, well, that is quite as simple, I would say. Like you have one or two switches, top of rack switches, and then you have multiple servers connecting into it. That's a rack. And what is a logical device then? Well, you will see more then. It's like I mentioned, like a Lego device. So like a building networks, building blocks for the network. So this is, once again, it's the only logical things. And once you've decided I want to create this, what you do then, take the logical device and you try to map them into a form factor. And it could be like 8 times 100 plus maybe 48 times 25, which is like, you know, similar to QFX 5120. And that one could then be mapped to like the physical device. And as you know, 8 times 100 and 48 times 25 could be for, of course, Juniper device, a QFX 5120, but that could also match into a Cisco device or Arista and so forth. So that's what you do in the end. I will show that doing the mapping in the end from this logical thing, abstraction layer into the physical device. And this is actually the same thing. And what you do then, once you've done the racks, you will build a template. But I go back and do the racks. And here I have already built one rack. And as you can see, this is one leaf switch, and you have a bare metal service connected over one link. And if you remember, going back, this is simulating this one. So the leaf and the bare metal server. Now I want to build this side, one leaf, 2 bare metal servers. So what I could do then, I can clone this one. And this one, I call it rack 2. It's a layer 3 class, not a collapsed one. I will call it rack 2. And here I have, I will show you later on what this means, but it's a logical device once again. And then I have the difference here. I will need 2 bare metal servers, if you remember. So I will call this DC1 2. I will need 2 servers, and now you can see on this side it changed into 2 servers. And these devices, the servers are like a 1x 10 gig interface. And we need some connections. And in this case, connecting to the DC1 rack 2. And then I should be ready, I hope. Now clone it. And this is, if you remember, looks very much like I have in JCL, 1 switch, 2 bare metal servers. And you might ask, what is the logical device interface maps? Well, if I go into these, as you can see, this is only logical devices, has nothing to do with real devices. But if I rather than go into the interface maps, this is where you can see, first of all, the multi-vendor support. You have, down here you have Arista, and if you specify and look only for the Juniper ones, we get a list then of some of the devices we have from the 2300, 5120, and so forth. And looking here, you can see device profile and how it maps into a logical device. So typically, if we go down to this one, for instance, 5120 48Y, you could map different kinds of logical devices. This is only need like 12, 1, and 210. But this is more commonly used, like 48 10 gigs and 8 40 gigs. And that could be used as you know, in 5120, sorry. And that also goes for this one. So if you use all the interfaces on full speed, more or less, you have 8100 and 4825, which is mapping very good into this device. But so now we have the racks, and then we want to build a template. And what is a template then? Well, going back here again, that's where you add the spines and racks into like a unit. So a template, they could be like pod-based, that's a 5-stage, but we only do like a 3-stage, so it would be rack-based. So I go back to my setup and doing the design, and the template here, I have to create one. So I give it a name, DC1 template. It's rack-based, it's not pod-based, that's like 5-stage, and it's not collapsed. I do want to have it using MBBGP, EVPN, and then I just add the racks I want. That's the first one, and add rack 2. And here you can see this is rack 1, and this is rack 2. But if you remember, going back to what the network looks like, we have 2 spines, spine 1 and spine 2. So what I need to do then is to add first what kind of logical device for the spine. And once again, I can use this one. And I need 2 of those, right? And then I can show links and see how they are connected. Bam. So now I have a template. And the last thing is building a blueprint. And what is a blueprint then? Well, a blueprint is like a running leaf and spine system. So that's where you incorporate this template. And the template, as you've seen, incorporates 1 or 2 or multiple racks. I just give it a name, DC1 blueprint. And then I pick the template I just created and create. It will take some time. I'm doing this in JShell, and for some reason, sometimes it takes a long time. Here we can see that we have not deployed anything yet. So that's the next step I need to do. And I see now that we are close to the hour, but I want to show you some things before we go into deploy this and see it actually working, Fabric up and running. As you can see here, nothing is deployed yet. So everything is just now within Apstra. Otherwise, the dashboard will show you the status of the whole network. Staged, this is actually where you build things before you commit. That's the same as on a Unix device. You commit it, and then once you've committed and you have no faults, then it goes into active. So this is actually the active running configuration of your Fabric. So in here, I need now to assign resources to the spine, leaves, and so forth. So the first thing I would do is assigning AS numbers to the spines. So it's quite easy just to give in the spines. And the same thing is for the leaves. DC1 leaves. And we need some loopbacks for the spines. And I'll take this one, the spines, and of course the same thing for the leaves. And for the links between the spines and leaves, I need some IP addresses as well. So in this case, I will use the DC intra Fabric ones. So now I have assigned those IP addresses. The next thing I need to do is like here we do the mapping. So now I have just a logical device in this case, but I want to map this into something more workable, so to say. So in here, then I will map this into virtual QFX. And as you can see, I could have chosen like an Arista or Cisco virtual, but of course, in this lab, we're using only virtual QFXs. So all the spines and leaves in this lab will use a virtual QFX. And then I do the update. So that's for the networking devices. We will do the same thing on the server side. And in here, in this case, we're using CentOS. We could use something else, but I use CentOS image. And let's do the update. The next thing we need to do is to sign some system ID. And I happen to know this is like, this is the management IP addresses of each device. So I know this is ending with 201, and this will be 202, and this is 203 and 204. I won't need that for the servers since they are layer 2 only. So now we have done like assigning and preparing for doing the underlay, and now we need to do the overlay. And how do we do that? Well, it's quite straightforward, I would say. So what we do now is going into the virtual, and the first thing we want to do in writing zone, that's a VRF. So I can create DC1 VRF. I could add some more routing policies, but in this case, I just use it in default. So that's the first thing I do. And as you can see here, we need to assign some resources to this one. So some loopbacks. So once again, the leaf loopbacks, the pool we used previously. So I assign this, and for the VNIs, we use the default pool, which is this one. And then I save it, and then this will go green eventually. And then, if we remember, the last thing we want to do is adding the virtual networks, the VLANs. So I will create 2 of those, and those will be VXLAN based, and I will call them the virtual network 1. And we will use the VRF. We just, sorry, we will use some, of course, we use some layer 3. So I will give them some IP addresses for this subnet. And we need a virtual gateway as well. 168.100.1. And we use untagged for this one. And if you remember, those will be assigned to both racks, because the blue virtual network, you remember, were actually on both leaves. So that's the first virtual network. Soon it will be seen here in the view, and I will configure the second one. And here I will do the same thing as previously. I will assign some pools on this one, and there you go. And that will turn green very soon. And I will have to create the second one, which is VXLAN based. Give it another name. Another network, of course. 24. And gateway 200.1, and we do it an untagged as well, and we assign it only to, if you remember, that should only reside on the leaf on the right side in your network. So soon we have everything in place, and then we'll launch it, and then we're going to take a break. So now we have everything in place. As you can see here, we have a lot of things uncommitted. So this is very much like a UNOS device. So the next thing here now is to actually commit. So when I do this, Apstra will build the database in the background, derive the configuration, send it out, and we will have the active network here will eventually go green, and we can see the status of the network in the dashboard. So I do the commit here, and I give the name of this version, because we will use this rollback functionality later on. And then start doing the commit, and now things start happening in the background. So this is typically like where you see what is happening. And as you can see here now, as the network is converging, it takes some time using virtual QFX and JCL. It will still be red. So now, right now, when the BGP is not up and running, we haven't seen the routes being advertised and so forth. It would take some time, but hopefully then before the break now in 1 minute or so, everything here will go green. And then we have done the underlay, the overlay, using the graphical user interface. We have then created the configurations from the database and using these agents, off-box agents, and by using netconf or SSH, and send out the configuration to each and every box. So this takes some time. And active, this is actually the real network. So this is the real network, and staged, this is where you build new things. And then you, after you have done that, you then go into commit, and then it's being launched into your active network. Still not fully ready. Sometimes it takes a couple of minutes, but what you can see here is like the BGP has not converged yet. That's the reason. And that also goes once the BGP is not up and running fully. The route table, of course, is not working as expected or our intent. So give it maybe 1 minute or so, and hopefully then we should be up in, everything is green. Meanwhile, any questions out there? No, I don't see any questions. And there you can see everything then has turned green up here. And then if you go into looking into anomalies and so forth, everything is just green. So we succeeded building like a overlay underlay EVPN VXLAN for a very small DCI data center, sorry. But you can do this easily, less like in 15-20 minutes once you've done this a couple of times. So with that said, I think we take like 5 minutes break. So 5-minute break from now. So see you back, and then we do some more demo on this one, and then look into also another demo, which is like on DCI and the promotion and software resources. So 5 minutes from now, please take a break. So I think we have passed like 5 minutes. So welcome back for those who are still on this webinar. So the next thing then, as you can see here for the agenda, is doing some day 2 operations with Apstra. So as you probably know, what we've done now is like day 0, day 1, but now you have your network up and running. So what could you do with Apstra in like a day 2 operations? And one thing that you could do, for instance, if you remember, one thing missing is like if you want to do MACsec, or if you want to do, like in this case, it will only like introducing like a name server, which is a quite easy use case, but more advanced and maybe more useful for like a real case scenario. If I want to do like MACsec between my data centers or within my data center, how is that done? That is done by using configlets. And what is that? Well, configlets is like, I will import one here. I made one previously, like adding a name server. And as you can see here, it's like quite basic. It's just adding a name server. That's it. But this could be then, rather than having this configuration, it could be like introducing like a MACsec configuration and send it out to, in this case, most likely not the spine, but maybe a leaf. And then I import it. I haven't assigned it yet, so I will see here in my uncommitted, like I have a configlet is added, but still I need to commit before it's being sent out. So if I log into, for instance, am I connected or not? No, I'm not. Okay. Connecting, okay. Am I disconnected? Okay. Never mind. I'll go back here then. So that's uncommitted. So now when I do committed, add names server. Once again, this is just to keep track of your configuration versions of the fabric. So if something goes wrong, which I will show you, then you can then go back. So now it's being sent out and everything goes green. And what we could do then is looking into the active. So this is actually the network is up and running, and we can pick and choose just one device and go into the configuration. And as you can see here now, here we have the name server attached. If I for some reason say, I don't want that, I want to change that, then I could go back and go into Time Voyager and go back to the previous version. And sorry, is that no change to commit? But I do commit anyway. Remove DNS. I hopefully did. And then I go back into active again. And as you can see down here, something is happening. Okay, now it's done. So it's just the same thing, go into the config, and bam, I failed. For some reasons, it didn't add name server. I want to go back to jump to this revision, roll back to select the revision. So now it should be no DNS commit. Sorry about that. And I can just look into uncommitted, and then I have to commit. Okay, but now you can see the power of Time Voyager. So in here then, in the end then, you can have lots of versions, and depending on, for instance, during a maintenance window, you could then go in and change and go back to the one that worked maybe before you started your maintenance window. What I would do then is to see if you do the opposite. If you, for instance, go into a leaf and in here, you add some configuration. What does it look like on the Apstra side? So and we can just look into the configuration. As you can see here, we have everything for building a EVPN and so forth. But let's say if I want to do like add something here, I add like an NTP server. So system NTP server, I add less 1.239.350. Bam. And if I want to just to verify that actually this one was NTP, I can see, yeah, as you can see here now, I have this one in here, and what I need to do then is just do a commit, and then we have it. So what does it look like in the AOS side then? Well, now it's this, once again, it's like a virtual environment, it's JCL, it takes some time, but what we will see here soon, there will be some anomalies, because what we did now, we changed the intent, the original design, you can say, by going into one of the leaf switches and change from the golden config. So the golden config, that is like what you designed from the first place. And now you can see here, there's some config deviation. So I can click on this one, and I can see here now, they're just showing that this specific device, there's something wrong here. There's an anomaly, there's a config issue. And as you can see here, the actual configuration, the running one, is not according to the golden config. And then if you scroll down, you can see, this is all the changes. So what you could do then, either you accept this and then everything goes green, but then you have to keep track of this, or you do apply full config, and then what you do is like revert back to the golden config, and then hopefully soon everything here will go green again. And as you can see here, we have no anomalies when it comes to configuration and so forth. So that's a very good detection. If someone goes into like temporary things, maybe during the day or during service window, that you will be alerted about this is something going on. Do you really want to do this or not? And if you do not want it, you can then revert to your previous well-known stable configuration. And I just want to show you the last thing when it comes to fabric management, then what we could do. So in this case, like let's say if you want to do an upgrade, an RMA, and I have one of the leaves here, I want, for instance, to, now it's in deploy mode. So if I want to do something do an upgrade, for instance, I have to go to stage. This is where I do all the new configuration. I pick my device. In this case, the same thing. I change this from deploy to drain. And by doing this, then I then manipulate BGP. So this one will announce that by using AS path prepend, that I do not want any traffic to my switch. And by doing this, then you will then eventually have no traffic on this device. And then when it's being drained, and you can take it out, replace it, or do an upgrade of whatever you want. And after then you have done, you should be able to see some BGP anomalies now, but that may take some time. And then once you have done your draining and you want to bring it back, what you do then is like pick the same device, change it into deploy, update, and then you're back up and running. BGP is working as expected, and then you have traffic back and forth to that specific device. So that's just a few things. And once again, everything I've done here, more or less, could be found on not there, this one, this step-by-step instruction. So I encourage you to look into that. But now looks into one thing which is missing in this setup, and I think you have seen this, there's no DCI. So how do I want to, if I want to play around with this, maybe on my own server and so forth, how could I do that? Well, one way of doing it is using something we called build your own. So what is this? Well, what my colleague has done then, he has done a lot of scripting, put it on GitHub. You see the link here. And down here, you can do then build this topology you can see here. So we have a 5-stage class, a 3-stage class. You have a couple of servers attached to it. And we also have MPLS core between, and that we're using some virtual MXs and some, of course, within the data center, we're using virtual QFXs, and everything is managed by Apstra. So the reason for this is like two things. First of all, this is a way for you that if you look into specifically the GitHub, you have all the instructions how to build this and run. If you follow instruction and run the script, it takes like 15-20 minutes or so to get it up and running. And then you can start playing with this. And what is also included, you have also all the configurations. So you have the underlay, the overlay, and so forth is included in the scripting, which makes you have this up and running in like, 20 minutes, and you can start then playing with it in your own way on your own server, in your own premises. Because in EHL, unfortunately, we don't have this yet. So this is a good way as a complement, you could say, to the previous one, or if you don't have like lots of boxes on your own in your own lab to build this similar topology, which could be quite complex. But just a few things in this specific setup, we're using these versions of the virtual QFX and virtual MXs as well as Apstra. Of course, this could be changed, but that is according to the script. So if you go into, I think I have that. Let's see here. If you go into, so this is like the link. Gilberto, and here you have all the information about if you want to build this. Here you have all the IP addresses, the topology, how to get started is very well documented. What kind of server most likely you would need, and there's some other pre-deployment server configs, how you do with the virtual MX, and the preparing the environment, and also in this case where you can find the images needed in order to set up the Juniper environment. And if you want to do changes within on the right side, you have, once you have run the script, you can also have the like start topology, stop topology, and so forth, and even delete it. So it's very versatile in that sense. And once again, this is with the standard setup when it comes to IP addresses and the amount of devices. If you want to change something, there are some CSV files, so related to in each and every device type. So there, if you want, you can change it. So it will take some time maybe to understand the scripts, but it's a very powerful tool for you then to start working on this one if you want. And just looking into what is the setup. Well, in here, what we have is like, I go to the dashboard first. We have, sorry, I go to the blueprints. So I have two blueprints here. So I have blueprint 1 and blueprint 2, and we're actually 2 DC. So this is DC 1, and then I have the DC 2 here. So the only difference, if you remember, this is like 3-stage class, and this is the 5-stage class, and they're all connected to over DCI. And I think this is where you can play around and have some fun then with the DCI. So we can look into that specifically. So if we go into, if we go back to this slide. So if you go into what it looks like on this side, DC1, we can specifically look into the border leaf. How do you configure this one to get some traffic between DC2 using 2 border leaves on that side? And that's where we use the connectivity templates. In this case, then we have created some on our own. And what you do then is like you just assign those to those specific interfaces, or in this case, with the border leaves. But more importantly, we can look into what's inside of this. Well, here you have 3 components, you could say. First of all, the IP link. What it says then is like what kind of addressing we're using. Is an untagged. What's the routing zone? Is it with the default one? And the peering, of course, you need to understand what's the AS number on the other side, and the address, of course. And if I want to use any routing policy, this is where you can use them policy, but now we're using just the default one. So here is something you can play around with. You can remove this and build your own, or playing around with routing policies and so forth. So it's very much up to you. This is just to get it up and running quite quickly. And then what you can do, either use it for your internal works, or you could give it to customers, or you could use it for demos and so forth. Any questions on that? I don't see that. Okay, so then we will continue to the last part, which is coding and some other resources. So on the coding side, first of all, I want to show you on the partner portal, which I hope you all have access to. You can then choose Apstra, and in here you have lots of things. Okay, logged out. So once you log into and you choose Apstra, you will have lots of information related to not only the product, but also how to order it and some other promotions we have. So down here then, we have, if you click on this, you have things that will help you through the process. So all the way from prospect, qualifying, customize, prove, and propose. There are some links here with some valuable information in here. But I want to show you something that is quite recently released, at least like 5 months ago. There's a promotion in here. And what is that? Well, this is like something pre-packaged using building blocks. In this case, Apstra license. We have 3 different QFXs depending on role, like a border leaf, leaf, and then spine, leaf, and a border leaf, and then support and also some subscriptions. So that's the core, and you can add on top of that, going from 6 devices, you can add some more leaves if you want. And the idea behind this is to make it as simple as possible for you. But if I go into show you what is in the configurator or the CPQ, you will see these building blocks then turning up, which might not be well known, but we have something here which is called Datacenter. So in here, if you click on Datacenter, you come to something called Datacenter Fabric. So these are, soon you will see the QFXs that you saw in the building blocks. So you can pick and choose. I want all of these. Take some time, obviously. I want the spines, I want leaves as well. And come on. And then the licenses would do like a 3 years only. Advanced, and then I can just easily create a transaction, and then I think there will be an error here, and I have to click again. But that will show you then what is like a bill of material for this kind of setup. Of course, it's quite basic. If you remember from the promotion, you can add more leaves if you want. But now, the next step you will see here goes quite slowly. Here are the components. So the bill of material. First of all, they have 6 licenses, which is for Apstra, because we have 6 devices. We have 2 KFX 10K, 2 5200, and 2 5120. And then within here, then we have also included some optics, as well as licenses and support. So this is like a bill of material for a full-blown data center if you want. And this is part of the promotion. And the promotion then, what is that then? Well, there's another link here. So if I click on this then, so here you can see this is the building blocks, and down here we have a starter offer and extension, and that is, as I said, 6 devices to start, and then you can add up to 4 of those. And here we have some recommended minimum discounts, everything prepared, so hopefully it makes it easy for you and your customers to understand what is needed, and also some costs to get it quickly updated. Okay, any questions on that? No, I don't see that. So move on to some other resources. So if you want to learn more about Apstra in general, I would recommend to go into partner training, and of course the Learning Academy. Of course, on YouTube, there's a lot of things that Apstra has done. So you have either long or pretty short videos you can look into, anything from doing day 0, day 1 to day 2, and some quite advanced as well on graph queries and so forth. The VLabs, this is, as you know, for anyone. So anyone that register with the email address will, within most likely 24 hours, have access to VLabs. So there you can allocate just what I've shown in my first demo and play around with. And once again, it has this step-by-step instruction as well. And there's also in here, you can see in the bottom here, you have this intent-based networking for dummies. That's actually a PDF document if you can download if you want. And it's pretty good. So if someone is interested to have something to read, almost like a novel, that might be an option for customers or for you to get more updated. And last but not least, if you as a partner want to play around with Apstra software, we have, as of now, as some time to back, we have some restrictions on downloading. So it's good for you to know that if you want to download the Apstra software, you need actually to do what we call AOS and AOS 2 training. So that's for free. You can find it on Apstra Academy. It's like 2 times 8 hours, and it's very good. But once you have done those, then you're able to download the software. So please do that. And in worst case, of course, we can help also to provide the image if necessary. That's about what I would like to talk about today. Is there any more questions out there? I don't see that. So if there are no more questions, then I will hand over to you then, Sarah, and say that we are done with this webinar for today.
Okay. All right. Thanks so much, Eric. Thanks, Matu. And thank you, everyone, for taking your time to attend today. We look forward to you joining us for part 3. And we wish you a pleasant afternoon. Thank you very much.